Hey everybody, I'm in Unity and I'm ready to enhance my Unity game. So one of the things I like to do is set my testing to maximize on play. I want to show you where we are starting at based on my last tutorial. If I'm holding down my mouse and it takes a while to get moving. And so what we need to do is we need to speed things up. And so we're going to add a speed multiplier to our script. And we're going to add, we're basically going to speed it up so it goes faster, but we're going to try to limit our speed. So we're not going to let it go beyond a certain amount. And then I hope we have time. I think we can also add a jumping mechanic to our game. So what we're going to do is we're going to edit our player controller script. So the way to do that is you can just double click on that player controller and it should just open up Visual Studio. And yes, it did. So here we go. All right, so we're going to add some variables here. First thing we want to do is we're going to speed up this add force. Oh, there's one other thing I did not do, which I intended to. I'm not sure why it's not done this way. This is supposed to be fixed update, not just update. Okay? So we're not just working on update. We're going to work on fixed update. Okay? So what we need to do is, I like update, but I'm going to just do the following here. I'm just going to go over here and hit enter. I'm going to type void fixed update, like that. Isn't that cool? You just start typing it out and it does it for you. So I'm going to cut this and move it over. I don't know why I did it that way. I must have just forgotten everything I had learned about fixed update and update. So Control X, cut from there, paste in here. Okay, so what we're going to do is, as of now, we're doing this input get access horizontal, and when we add a force, we're adding just a little bit at a time, so it takes a while to get up to any kind of a decent speed. So we're going to speed that up, and we're going to multiply this movement by a certain amount. Now, if I could, theoretically, right inside of here, put like movement times something else. But instead of that, I'm going to create a variable for it because I want to be able to fiddle around with the numbers. And so anytime you're dealing with numbers that you're going to use, and you may want to use other ways, you might want to create a variable for it. So that's what we're going to do. This variable is not going to be private. It's going to be public. And we're going to call it speed equals 10.0 capital F, like so. Okay? Now, by making it public, oh wait, it's red because it doesn't know what data type it is, so I need to tell it it's a float. Float is a precise number with a decimal point. Okay? So in this case, 10.0, and this capital F indicates it is a floating point number. Okay, so this is just characteristic of the C# language, you need that F there. Okay, so now watch what happens. I'm going to save my changes, and I want to show you what my script looks like in Unity now that I've saved my changes. So I go over here, I get into Unity, and as soon as I kind of click it and interact with Unity a little bit, you'll suddenly see speed has now appeared down in this window here. That's because speed is a public variable, and as a public variable, I have access to it right here in Unity. But I don't see m_rb. Let's go back. So you'll notice the rigid body, MRB, is private. As a private variable, we don't have access to it outside of the script. Okay, so hopefully that makes a little bit of sense. So the first thing we're going to do is speed it up. So I'm going to go to public float speed. And when we add our force, now let me just collapse these other ones and get rid of some line return so you can kind of see the variable speed as well as the others. I'm going to hide that as well. Just clicking the minus sign, and we see speed up here. We have access to it now. So when we add our force for movement, we're going to multiply movement by speed. Just put a little asterisk for multiplying. It's the multiplication operator. Asterisk is to multiply. And I'm going to, now watch this. You notice how my code is starting to go off of the screen. And I have to kind of scroll to the right a little bit to see it. My recommendation is if your code gets that long, you need to break it up. Okay. Now, I've zoomed in, so I probably have a little more speed. If I wasn't zoomed in so much, if I was just coding for me and a project, and I wasn't showing this on a video, that's probably wide enough. You don't need to do a new line return, but for the sake of the video and just to show you, after this comma, I'm going to hit a line return. So I hit enter, and now you can see that this add force function, in this case actually technically it's a method, it begins on line 22 and it ends on line 23. And this extra line return is just ignored by Unity. Okay, it's to make it so the code is more accessible what we have here. I'm going to save my changes. And close that little warning sign there. I'm not sure what I did to get it to do that. But now we've added this little piece here. It's movement times speed. Let's go ahead and test that out and see how it's working. Before we test it out, I just want to emphasize a few things. I know some of my students sometimes will have trouble. If things don't look right, color doesn't look right, that's usually because there's a mistake somewhere, or if it's not readily recognizing some things. Make sure, for example, we made a quick change to void update. Understand here, void update has nothing inside of it, right? It's just empty. So we have this void update, and then there's nothing because we moved it to fixed update. I wanted to leave this. We are going to come back to this. At some point, we're going to use that. So that's why I left it there. But notice it opens here, closes here. This is a method, and this method it gets called once per frame. It's called update, and anything you put in there will get called. Fixed update gets called on a regular, consistent basis. It may mean that because of the update, it might be cycling more frequently, and it may not always trigger fixed update. It will trigger it when it needs to, basically keeping as consistent of an execution as you can. In other words, it runs on a consistent basis. All right, so let's go ahead and save our changes and test it out. And so I'm just going to go ahead and press play, and you'll see how much faster it is. You see that? I can just go flying off the screen. Okay. Now the problem is that we can just keep holding it down and we'll just go faster and faster. And as we get to greater worlds or we make them larger, that's going to cause some problems. So we're going to basically set a maximum speed and do a thing called clamp, which will make sure it never goes greater than the maximum speed in either left or right direction. So to do that, we're going to create another public variable. And right after we declared speed. So it's also public. And it's also a floating point, and it's called max speed for maximum speed. And we're going to set it to begin with at 12.0, and then we'll play around with this in a moment so you can see, and you can adjust it to get it how you want it to be. And we're going to save our changes. And then, so now once I save my changes, that variable is now recognized in Visual Studio. So what we're going to do is we're going to change fixed update a little bit. And so this is going to require a little extra code. So I think what I'll do is I'll code it, and then we'll talk about what I did to code it. Let me show you just a little bit about here. When we're working with Visual Studio, there's this whole thing called IntelliSense, and it kind of guesses what you want to do. So I type the letter M, and it immediately recognizes this multi-line attribute with this M_RB, and it's highlighted. If it's highlighted, all I have to do is hit the Enter key, and it shows it there. So we're gonna adjust the velocity of the rigid body. And one of the things I want to show you is as soon as I hit a dot, suddenly it's going to give us some code hints. The code hint that like add explosion force, which sounds really cool. I'd like to try that out sometime. Add force or position. All of these are methods. So these are things that we can do with our rigid body. Then these that have the little wrenches are basically settings. They're technically variables, also known as properties. So like a rigid body has an angular drag, and it has an angular velocity, and it even can have an animation. So one of the things you can do is you can see what's available. And if you know what you want to do, like velocity, for example, and I type V, it actually highlights it. So I don't actually have to remember how to spell velocity, which, I mean, I do know how to spell velocity, but I don't have to type it all out. It's already highlighted. All I have to do is hit Enter again. And one of the interesting things about a velocity, and I'm going to hit a little dot here, is I want to show you, for example, X. When I type X, you have velocity. There's X, Y, and Z. So velocity is a vector 3. Velocity is a vector 3. So you see what I did there, velocity.x. Okay, so now I'm going to code it and I'll explain what I did. So instead of doing the dot x, I'm going to say velocity equals. So the idea here is once I've added a force to my rigid body, I'm going to make sure its velocity is not greater than the maximum speed going to the left or going to the right. So I'm going to use that maximum speed. But in order to do it, I have to reset the velocity, and that's using a new vector 3. And I just want to show you, there is basically, that's kind of what we need to do. And inside of here, we're going to set it, it's x, it's y, and it's z velocity. And I'm going to hit enter just to make it, I'm going to hit enter 2 times just to make it a little easier for you to see, because it's not all going to fit on one line. Okay, in our vector 3, we need to give it basically x, y, and z. And the way I'm going to do this for x is I'm going to do this cool little thing called math. There is a math library called Mathf for a collection of common math functions, F for functions. I'm going to hit a dot here, and there's all these math functions we can do. And one of the ones I really like in game design is this one called clamp. And now notice, you read that. You might want to zoom in, or I'll zoom in for you on the video, is it says it clamps a value between a minimum float and a maximum float value. Okay, so the minimum would be moving to the left, which is a negative velocity, and the maximum would be a positive velocity. So I do this math.clamp, and now I'm going to give it 3 values. Okay, so the first value is going to be what I'm changing, and that's that m underscore b dot velocity dot x. And now you notice how I hit enter and nothing happened. It went to the next line. And that's because it wasn't highlighted. So I do the down arrow, so I highlight it. Now I hit it, and now I want it to set x. It's currently highlighted, so I hit enter, which of course that's pretty lazy. I could have just hit enter to begin with. And that's what I'm changing. So when this math.f clamp is done, it's going to send me a number. And the lowest number it could be would be negative maximum speed. So that's the minimum float. I have to put a negative sign, max speed. And then the maximum would just be max speed, like so. So what Mathf Clamp does is Mathf Clamp sends me a value. It looks to see what velocity x is. If velocity x is between negative maximum speed and maximum speed, that's what it sends back. If velocity x is less than negative 12, it will send me negative 12. So it will never be lower than negative 12, and it will never be greater than 12. Now, we can't just set y. We have to say what it's the y for. So we're going to go ahead and add that. So it's m underscore rb dot velocity dot y. And then I'm just going to copy that right there. That's a little bit easier. And Control C, Control V, like so. And that's the new vector 3. And now we're going to save our changes. But before I do, I'm going to set that maximum speed to something low. Because I want to show you this working. The best way to show you that it works is by giving you a lower value than 12. So let's set it to, say, 4. Okay. We're going to set that to 4, save our changes, and then try it out. We're going to try it out. And now the best way to try this out is once we're in here, get to the edge of the screen and see just how fast I can get this thing going. I'm holding it down, and that's as fast as this currently goes. Okay. Now watch what happens when I change maximum speed on here back to 12. I want you to see that this maximum speed is indeed working. Hold it down. Wait till it gets to the edge. Here we go. Hold it down. Now look at it. You see it just like it barely dropped vertically, and it was way off the screen here, whereas before it dropped down there. So the maximum speed is indeed working. So the main thing we want to do is go back to our script and set it back to 12. If you think that's too fast, then scale it back. type in a maximum speed of 8, and just play around with those numbers until you got the number that you like. So at this point, here's our code, and let me just kind of like minimize that start, and I think we can see just about all of our code in one window. There it is, maximum speed, like so. In fact, let's do this so it's a little easier to read. I'm going to backspace here, just so you see. I'll put a space in there, and we'll go back here. This will allow us to see it a little bit easier, so you can see all of my code right there. Zoom just down a bit. There we go. So you can pause this and check it out. So now that I've tested it out, I should show you, because I haven't been doing Git. One of the things I did is I checked to see what's been modified, and the work I did today only changed the Playercontroller Script and the scene. So I've added it here, I committed my changes here, and I'm about to push it to the online repository, and I will do that there. So anyway, I'm basically, at this point, done with this. I think my next tutorial will cover the jumping mechanic. Sorry, I ran out of time. You can stay tuned for that one. I should be posting that relatively quickly. So anyway, I'm going to go ahead and get out of here, and stay tuned for that video. Thanks for watching.